Welcome to Creata classes. In this lecture, we will cover the problems on the segments of the triangle. We have specially placed the problem section in the end of the course so that we can plan questions from all the sections. The questions in the segment of triangles are generally mixed in nature, that is, it involves concepts from multiple topics. So we have planned the question series after completing all the topics. This will really help you a lot. Further, we have wide range of questions. Before moving further, all to go to the download section and download the complete formula and the concept list. Take the printout and keep it with you. It will help you in correlating the fundamentals with the questions. In each question, you can pause the video and try to solve the question on your own. This will open your analyzing portion of the brain. Believe me, this will really help you a lot. You will be able to understand how to analyze the question and how to approach the question. And from our side, we will also analyze the question and we will tell you how to approach each question. So let's begin with our first question. The question is, triangle ABC is an isosceles triangle with AB is equal to AC and AD as the median to base BC. If angle ABC is equal to 35 degree, find the angle BAD. Let's see how to approach the question. So first of all, our first step, that is, we will observe and visualize the question. In the question, a triangle ABC is given, which is an isosceles triangle. We know isosceles triangle is a triangle which is having two sides as equal to each other. So triangle ABC is an isosceles triangle, and it is also given AB and AC are the two sides which are equal, that is the two sides of an isosceles triangle which are equal to each other. Further, in the question, a median AD is given. We know median is a line segment that starts from the vertex and which joins the midpoint of the opposite side. If AD is the median, means D is the midpoint. And if D is the midpoint, means BD is equal to DC. This is the observation that we have to observe while reading the question. Further, in the question, angle ABC means this angle is given as 35 degree. We have to find angle BAD, means we have to find this angle. So we have visualized the question and we have observed the question. So let's see how to approach the question. The approach is that in the question it is given as isosceles triangle. And whenever you see the word isosceles triangle in the question, the first observation that you should get in your mind is that the angles opposite to equal sides in an isosceles triangle are equal to each other. Here these two sides are equal, means the angle opposite to these two sides will be equal to each other. Means angle B and angle C are equal to each other. Whenever you see the word isosceles triangle in the question, then this fundamental should automatically trigger in your mind. That is, the angle opposite to the equal sides are equal. Further, we have to find this angle. Somehow, if we are able to find angle ADB, means this angle, then we can apply the sum property of the triangle, that is, sum of three angles of a triangle is equal to 180 degree, and we can find our missing angle, angle BAD. So somehow we have to find this angle. Further, in this question, are you able to observe triangle ADB and triangle ADC are congruent to each other? Let's see how. Here AB is equal to AC, that is given as a triangle is an isosceles triangle. Further, angle B is equal to angle C, that just we have proved as equal. And AD is equal to AD, that is the common side. So we got both the triangles are congruent to each other. Now if we apply the CPCT, that is the corresponding sides and corresponding angles of two congruent triangles are equal. So we got angle ADB is equal to angle ADC, means both of these angles are equal to each other. And BC is a straight line, means sum of both of these angles is equal to 180 degree. Okay, linear pair axiom we have applied. So we got angle ADB is equal to angle ADC, which is equal to 90 degree. That is, both of these angles will be equal to 90 degree. We got our angle ADB. Now we will apply the sum property of the triangle, that is the sum of three angles of a triangle is 180 degree. So we got our missing angle, that is angle BAD is equal to 55 degree. Got it? This is the answer. So the fundamental that we have used in these questions are, the first fundamental is that the angles opposite to equal sides of an isosceles triangle are equal. So we got both of these angles as equal to each other. Further, we have applied the funda of congruency, that is both of these triangles are congruent to each other. Then we have applied the fundamental of the angle sum property of a triangle. These three fundamental we have applied. The observation that we got from this question is that in any isosceles triangle, say ABC, with the median as AD, both of these angles are equal to 90 degree, and both of these triangles are congruent triangle, and both of these angles are equal. So further, if you got any questions on median inside an isosceles triangle, we can say both of the triangles are congruent triangle and the angle at the base of the median is 90 degree. Okay, this is the observation that we got from this question. You should know and you should note such type of observation, because these observations are very helpful to you in solving the questions in the competitive exams. Okay, it saves a lot of time. Moving further to our next question. The question is, in a triangle ABC, medians AD and BE are perpendicular to each other and have length 12 cm and 9 cm respectively. Then the area of the triangle ABC in square centimeter is, okay, we are having four choices. A is 80, B 68, C 72 and D 78. So first of all, our first step, that is we will observe and visualize the question. Let's read the question again. In this question, a triangle ABC is given. Okay, let's draw a triangle ABC. Two medians AD and BE are given. These are two medians AD and BE. These are medians, means point D and point E are the midpoint of side BC and AC respectively. Further, it is given as AD and BE are perpendicular to each other, means the angle between both of these median is 90 degree. Further, it is also given the length of AD is 12 cm and length of BE is 9 cm. Further, we have to find the area of the triangle ABC. Let's see how to approach the question. In the question, we have to find area of this complete triangle ABC. Now we will try to recall the fundamental which involves the median as well as the area of the triangle. In the medians, we have covered that the median divides the area of the triangle into two equal parts. Area of these two triangles will be equal as it is divided by the median. Further, we have also seen the three median divide the area of the triangle into 6 equal parts. Means area of these small triangles will be equal to each other. Medians divide the area of the complete triangle into 6 equal parts. So this fundamental will be used in solving the question. Let's see how we use this. Further, in the question, it is also given as the length of the median. Now we will try to recall the fundamentals regarding the length of the median. In the medians, we have observed that the centroid, that is the intersection point of the three medians, divide the median into the ratio of 2:1. Let's try to apply the same fundamental in the question. First of all, let's mark the intersection point of these two medians as point G. Okay, G is the centroid. So we got AG is to GD is equal to 2:1. And the length of AD is given as 12 cm. So we got the AG as 8 cm and GD as 4 cm. Okay, the ratio of AG is to GD is 8:4, that is 2:1. Similarly, the ratio of BG is to GE is also 2:1 and the length of BE is given as 9 cm. So we got BG as 6 cm and GE as 3 cm. Okay, we got the ratio as 6:3, that is 2:1. So we got length of all these four segments. Further, if we observe the triangle AGB, this small triangle, can we calculate the area of this small triangle? This triangle AGB is an right angle triangle. That is, angle G is 90 degree angle. Let's apply the formula of area of triangle, that is half into base into height. Here if we take AG as a base, that is 8 cm. Okay, we got GB as the height of the triangle, that is 6 cm. Let's see the area of the triangle. We got the area as 24 cm square. But in the question, we have to find the area of the triangle ABC, that is this complete triangle ABC. Now here comes the fundamental of the medians that we have studied. That is, the medians divide the complete area of the triangle into 6 equal parts. So can we say area of the triangle ABC is equal to 3 times area of triangle AGB? We got area of triangle as 24 into 3, that is 78 centimeter square. That is the answer of the question. So we got the area of the triangle as 78 centimeter square. So the fundamental that we have used in these questions are, the first fundamental is that the centroid divide the median into the ratio of 2:1. The second fundamental that we have used is the area of the triangle as half into base into height. And the third fundamental that we have used is the medians divide the area of the triangle into 6 equal parts. These three fundamentals we have used to solve the question. Got it? So moving to the next question. The question is, in a triangle ABC with sides 6 cm, 7 cm and 8 cm, the angle bisector of the largest angle divides the opposite side into 2 segments. What is the length of the shortest segment? So our first step, that is, we have to observe and visualize the question. So in this question, a triangle ABC is given. The three sides of this triangle is given as 6 cm, 7 cm and 8 cm. Further, in the question, it is given as the angle bisector of the largest angle. If you observe the figure, the side 8 cm is the largest side. And we know the angle opposite to the largest side is the largest angle. So we can say the angle A is the largest of the three angles. And the question is mentioning about the angle bisector of the largest angle. Means from this largest angle we have to draw the angle bisector. Let's draw the angle bisector. Further, in the question, it is given as this angle bisector is dividing the opposite side into 2 segments. Okay, these are the 2 segments. And the question is asking about the length of the shortest segment. Let's see how to approach the question. Are you able to observe this figure is resembling our angle bisector theorem figure? As per our angle bisector theorem, we have seen in our angle bisector lecture, that is, the angle bisector divide the opposite side into the ratio of the 2 remaining sides. Means, if we say this segment as A and this segment as B, we can say the ratio of A is to B is equal to 6:7. That is the ratio of these two sides. The ratio of A is to B will be equal to ratio of these two sides, that is 6:7. Now we got the segment A is the smaller and the segment B is the larger. And the question is asking about the length of the shortest segment. Means the question is asking about the length A, that is this segment. So we have to find the value of A. Just simply applying the fundamental of the ratio and proportion, we got the value of A as 8/13 into 6. Okay, 6:7. So 6 plus 7, it is 13. So we got the value of A as 8/13 into 6, that is 48/13. That is the answer of our question. The fundamental that we have used in solving these questions are, the first fundamental that we have used is the angle opposite to the larger side is the largest angle. The second fundamental that we have used is the angle bisector theorem. That is, the angle bisector divides the opposite side into the ratio of the 2 remaining sides. So based on these two fundamentals, we have solved the question. Let's move to the next question. The question is, the length of 3 sides of a triangle are 6, 8 and 10 cm. The length of the median to the greatest side is then. 4 choices are given. A is 5 cm, B is 8 cm, C is 4.8 cm and D is 6 cm. So as per our first step, we will observe the question and we will try to visualize the question. Let's observe the question. In the question, a triangle is given which is having the 3 sides as 6, 8 and 10 cm. If you observe, 6, 8 and 10 are the Pythagoras triplet. Means if we form a triangle from 6, 8 and 10 cm, it will be a right angle triangle. Let's also check the same. We know in a right angle triangle, the hypotenuse square is equal to sum of the square of 2 legs of the triangle. Here 10 centimeter is the largest side, means 10 centimeter will be the hypotenuse for this triangle. 6 square plus 8 square, it will be 100, and 10 square is also 100. These three sides are fulfilling the Pythagoras property. Means 6, 8 and 10 are the Pythagoras triplet. That is, these three sides will form a right angle triangle. Let's form a right angle triangle. Okay, these are the three sides, 6, 8 and 10 centimeter. Okay, 10 is the hypotenuse, which is the largest side. Moving further, the question is asking about the length of the median to the greatest side. Here the greatest side is the hypotenuse, that is the 10 centimeter. And we know median is a line segment that starts from the vertex and it joins the midpoint of the opposite side. So for this hypotenuse, AD will be the median. If AD is the median, means D is the midpoint. That is, the point D is dividing the hypotenuse into two equal parts, that is 5 centimeter each. And in this question, we have to find the length of this median. Okay, let's find the approach to deal with this question. This is a right angle triangle and this is a median. So are you able to correlate this fundamental with the medians in a right angle triangle? In the lecture of the medians, we have covered the medians in a right angle triangle as a separate lecture. In that lecture, we have covered two topics under the medians in a right angle triangle. Okay, these are the two fundamentals that we have covered in the lecture. In this question, the first fundamental will be applied. That is, in a right angle triangle, median to hypotenuse is equal to half of the hypotenuse. Means the median which is connecting to the hypotenuse in a right angle triangle is equal to half of the hypotenuse. AD is equal to half of the hypotenuse. And we know half of the hypotenuse is 5 centimeter. So the length of the median will be equal to 5 centimeter. Okay, that is the answer of the question. Got it? Very straightforward question. Two fundamentals are covered in this question. The first fundamental is that we have to identify the Pythagoras triplet. Here 6, 8 and 10 are the Pythagoras triplet. So a right angle triangle is formed from the Pythagoras triplet. Okay, this is the first fundamental. In the second fundamental, we have seen a property of the median, that is, in a right angle triangle, median to the hypotenuse is equal to half of the hypotenuse. Got it? Let's move to the next question. The question is, in triangle ABC with centroid G, if AC is equal to BC, what is the angle BGC in degree? Let's go step by step. First of all, we will try to visualize and observe the question. In the question, a triangle ABC is given. Okay, this is the triangle ABC. And centroid G is given. And we know centroid is the point of intersection of three medians. And in the question, it is also given as AG is equal to BC. Means this length AG is equal to BC. Let's try to approach the question. In the question, centroid G is given. And we know the centroid divide the median into the ratio of 2:1. Here, if we extend the line AG to meet the point D at the side BC, can we say AD is a median? AD is the median because it is passing through the centroid G. If AD is the median, then D will be the center point of the side BC. D is the center point, means BD is equal to DC. Okay, this is the one observation that we got from the question. The second observation is that the centroid divide the median into the ratio of 2:1. Means AG is to GD is equal to 2:1. That is, AG upon GD is equal to 2/1. We got AG is equal to twice of GD. This is our second equation. In the question, it is given as AG is equal to BC. Can we replace AG with GD by 2? The same we have just proved. Further, can we write BC as BD by 2, which is equal to DC by 2? Okay, D is the midpoint, so BC is equal to half of BD and half of DC. So we got the relation, that is GD is equal to BD is equal to DC. Moving further, if we join BG and CG, can we take the triangle BGC out of the figure? Here in this triangle, GD is equal to BD is equal to DG, that is, these three line segments are equal to each other. In other words, can we say the point B, G and C are equidistant from the point D? Okay, these three line segments are equal to each other. Are you able to correlate this fundamental with the fundamental of the circle? Here D is the center and DC, DG and BD are the radius of the circle. We can form a circle with the center as D and these three line segments as the radius of the circle. Got it? So we got a circle around this triangle BGC. Moving further, here D is the center, means BC is the radius. And in the circles we have done the fundamental, that is the angle subscribed by the diameter at any point on the circumference is 90° angle. Means this angle will be equal to 90°. Why? Because this angle is subscribed by the diameter of the circle at the point G on the circumference. So this angle is 90°. That is the answer of the question. Okay, got it. Angle BGC is equal to 90°. That is the answer of the question. Further, we can have one alternate approach also. Let's see what is the alternate approach. If we observe these two triangles, here these three line segments are equal to each other. Can we individually say these two triangles are an isosceles triangle? In the first triangle, DB is equal to DG. Two sides of a triangle are equal, means this triangle is an isosceles triangle. And we know the property of an isosceles triangle, that is the angle opposite to the equal sides are equal. Here these two sides are equal, means these two angles that is opposite to these two sides must be equal. Let's give the name to both of these angles as angle alpha. Both the angles are equal. Similarly, in this triangle, can we say both of these angles are equal, as these two angles are also opposite to these two equal sides. Let's give name to both of these angles as angle beta. If we take the triangle BGC and we apply the sum property of the triangle, that is triangle of a triangle is 180°, we got alpha plus beta plus this angle which is equal to alpha plus beta. On solving, we got twice of angle alpha plus beta is equal to 180°. On solving, we got alpha plus beta is equal to 90°, and alpha plus beta is this angle. So we got angle BGC is equal to 90°. That is the answer of the question. There are many alternate ways to solve the question. You should know each way to solve the question. This helps you in having a wide approach to solve the question. So the fundamental that we have used in this question, the first fundamental is that the centroid divide the median into the ratio 2:1. The second fundamental that we have used is the diameter subscribe the angle of 90° at any point on the circumference of the circle. And the third fundamental that we have used is in an isosceles triangle, the angles opposite to the equal sides are equal to each other. These fundamentals we have used to solve the question. Let's move to the next question. A circle is inscribed in a triangle ABC. It touches the side AB, BC and AC at the point R, P and Q respectively. If AQ is equal to 4.5 cm, PC is equal to 5.5 cm and BR is equal to 6 cm, then the perimeter of the triangle is, four choices are given. A is 30.5 cm, B is 28, C is 32 and D is 26.5. The first step is we will observe the question. Here in the question, a circle is inscribed in the triangle ABC. Means this circle is the in circle, that is the circle which is touching the three vertex of the triangle. Further, these three line segment, that is AQ is given as 4.8 cm, PC is given as 5.5 cm and BR is given as 6 cm. We have to find the perimeter of the triangle. Means we have to find the complete three sides of the triangle so that we can find the perimeter, that is the sum of three sides of the triangle. Further, in the incircles, we have done the fundamental, that is the three sides of the triangle are tangent to the incircle. Means these three sides, that is AB, BC and AC will act as tangent to this inscribed circle. And we know the property of the tangent, that is the tangent drawn from any external point toward the circle are equal. Here, if we assume A as an external point and AB and AC, that is the two sides of the triangle, as an tangent, can we say AR is equal to AQ? And AQ is given as 4.5 centimeter. So we got AR as also equal to 4.5 centimeter. Further, in the similar way, we can say BP is equal to BR. Okay, B is the external point and these two are the tangent to the circle. Further, we got CQ is equal to CP. So we got all the line segments of the sides of the triangle. Let's find the perimeter of the triangle. Let's add all these line segments. We got the perimeter as 32 centimeter. That is the answer of the question. Got it? So the fundamental that we have used is, the first fundamental is that the sides of the triangle are tangent to the incircle. The second fundamental is that the tangent drawn from any external point toward the circle are equal. So these two fundamentals we have used to solve the question. Let's move to the next question. Refer the figure. In triangle PQR, I in center, O orthocenter, C circumcenter, Q and R vertices lies on the circle. Then find the angle P. 4 choices are given. Okay, we will go step by step. Our first step is to observe and visualize the question. In this question, a triangle PQR is given. This is the triangle PQR. For this triangle PQR, the 3 points are given that are in center, orthocenter and the circumcenter. And for this question, these 3 points are lying on a circle which is also passing through the two vertex, that is Q and R. We have to find the angle P, that is this angle. Okay, let's proceed with the question. Let's join point Q and R with these 3 points, that is I, O and C. Are you able to observe 3 angles are formed? Angle QIR, angle QOC and angle QCR. These angles are angle formed at the incenter, the angle formed at the orthocenter and the angle formed at the circumcenter. And we know the formula of these 3 angles. Okay, we have done in the comparison lecture also. We know the angle at the incenter is 90 degree plus half of the opposite angle, that is P by 2. And we know the angle formed at the circumcenter is twice the opposite angle, that is twice the angle P, that is 2 times P. And we know the angle formed at the orthocenter is 180 degree minus opposite angle, that is angle P. So we got the 3 angles formed at these 3 points. Are you able to observe these 3 angles are subtended by the chord QR at point I, O and C? The fundamental of the circles are coming into the picture. It means that these 3 angles are coming in the same segment of circle, and we know the angle in the same segment of circle are equal to each other. Got it? All these 3 angles will be equal to each other because these 3 angles are coming in the same segment of the circle. Further, we got these equations. Okay, we can take any of the random 2 equation and we can solve for the angle P. Let's take the first 2 equation. On solving, we got angle P as 60 degree. That is the answer of the question. So the fundamental that we have used to solve this question is the angles formed at the incenter, orthocenter and the circumcenter. We have used these 3 formulas to solve the question. And the second fundamental that we have used is angles in the same segment of a circle are equal. Got it? Very simple and very straightforward question. Let's move to the next question. The question is, refer the figure. In the given triangle ABC, I is the incenter. Find the area of the triangle ABD. Okay, 4 choices are given, A, B, C and D. Okay, our first step, we will observe and analyze this question. A triangle ABC is given. Okay, this is a triangle ABC and I is the incenter. Okay, if I is the incenter, means AI, BI and CI will be the angle bisector for this triangle ABC. Further, angle BIC is given as 105 degree, that is the angle formed at the incenter. Two sides AB and AC are given as 10 and 12. Two sides are given. We have to find the area of the triangle ABD. Let's proceed with the question. By looking at the figure, we can observe that angle BIC is the angle formed at the incenter. And we know the angle formed at the incenter is 90 degree plus half of the opposite angle, that is angle A by 2. So with the help of this formula, we can calculate the value of angle A. We got angle A as 30 degree. We got angle A as 30 degree. Two sides are given for this triangle, that is side AB and AC, and these two sides are adjacent to angle A. So we can apply the formula of our area of triangle, which is equal to half into B into C into sine of angle A. Here B is 12 and C is 10, and angle A we have calculated as 30 degree. On putting the value, we got the area of the triangle as 30. 30 is the area of the triangle. We got the area of the complete triangle ABC, but in the question we have to find the area of the triangle ABD. So how to approach this question? We know the area of the complete triangle ABC. If somehow we got the ratio of area of these two triangles, we can get the area of the triangle ABD by the fundamental of the ratio and proportion. So now we will focus on getting the ratio of area of these two triangles. So here we will use the fundamental of the angle bisector theorem. Here it is given as I is the incenter, means AD will be the angle bisector. If we apply our angle bisector theorem, can we say AB upon AC is equal to BD upon DC? The angle bisector theorem, the ratio of the segments divided by the angle bisector is equal to the ratio of the two remaining sides. Here AD is the angle bisector, and the angle bisector AD is dividing the line segment BC into two segments, that is BD and DC. So we got BD upon DC is equal to AB upon AC. Okay, this is the angle bisector theorem. On putting the value, we got BD upon DC is equal to 5 upon 6. That is ratio of BD is to DC is 5:6. Moving further, can we say the ratio of the area of triangle ABD to area of triangle ADC is equal to ratio of their bases, that is BD is to DC? We have done the concept, that is the ratio of area of two triangles having the same altitude is equal to ratio of their bases. Are you getting how we have done this? These two triangles are having the same altitude. Okay, if you observe, both the triangles are sharing the common altitude, that is they are having the same altitude. If we take the area of the triangle ABD, it will be half into BD into H. Okay, here H is the altitude. Further, area of the triangle ADC is equal to half into DC into H. Here H is common in both the triangles. If we take the ratio of area of triangle ABD is to the area of the triangle ADC, half and H will cancel out and we will remain with BD upon DC. So we can say the ratio of area of triangle ABD to the area of the triangle ADC is equal to BD upon DC, that is the base of these triangles. And we know BD upon DC is equal to 5/6. So we got the ratio of area of triangle ABD upon ratio of area of triangle ADC is equal to 5/6. And we know area of the complete triangle ABC is 30. We have to divide the area 30 into the ratio of 5:6. So we got area of triangle ABD as 5 upon 5 plus 6 into 30. That is 150 upon 11. That is the answer of the question. Got it? We have applied the concept of the ratio and proportion. So this is the answer for this question. So what is the approach or the fundamental that we have used? We have used the formula of the angle formed at the incenter and we have calculated the opposite angle, that is angle A. Then with the help of angle A and two given adjacent sides, we have calculated the area of the triangle. The formula that we have used is half into B into C into sine A. After that, we have applied the angle bisector theorem. That is BD upon DC is equal to AB upon AC. After that, we have applied the fundamental of the area of the triangle having the same altitude. That is the ratio of the area of the triangle having the same altitude is equal to ratio of their bases. So with the help of these fundamentals and the formulas, we have solved the question. Let's move to the next question. The question is, refer the figure. O is the orthocenter of triangle ABC. Find the orthocenter of triangle OBC. Let's go step by step. Our first step is to observe and analyze the question. Here in this question, a triangle ABC is given. And these three line segments are the altitude of the triangle. Why we are saying so? Because in the question it is given as O is the orthocenter for this triangle OBC. And we know orthocenter is the point of intersection of three altitudes. So these three line segments are the three altitudes for this triangle. And what are altitudes? Altitudes are the line segment that start from the vertex and it is perpendicular to the opposite side. These three line segments are starting from the vertex and these three line segments are perpendicular to the opposite side. The question is asking about the orthocenter of the triangle OBC, means this small triangle. The coordinate of A, B and C are given. Let's proceed with the question. By looking at the question, are you able to remember the fundamental of the orthocentric system that we have done in the orthocenters? As per this orthocentric system, if we are having 4 points and we are forming a triangle with the 3 point and the 4th point is the orthocenter for that triangle, then if we take any of the 3 points, then the remaining 4th point will be the orthocenter for that triangle. What I mean to say is that for this triangle ABC, if O is the orthocenter, means we are having totally 4 points, that is A, B, C and O. If we form a triangle from any of the 3 points, say from point B, O and C, okay, a triangle is formed. And for this triangle BOC, the 4th remaining point, that is A, will be the orthocenter. So for this triangle BOC, the point A will be the orthocenter. Got it? This is orthocentric system. So we got the answer as A, that is the coordinate AP square and 2AP. Got it? Moving further, if we take the triangle AOB, then the point C will be the orthocenter for this triangle AOB. And further, if we take the triangle AOC, then the point B will be the orthocenter for this triangle AOC. Okay, the 4th remaining point will be the orthocenter. Got it? So we got our answer as A. If we assume if we don't know the orthocentric system, then how we will proceed this question? Let's see the alternate way also. The alternate way is our observing power. We have to analyze and observe this question. Let's see, here ABC is the triangle and O is the orthocenter. All these 3 line segments are the altitude, okay, and O is the orthocenter, that is the intersection point of 3 altitudes. For this question, we have to find the orthocenter for this triangle BOC. And we know orthocenter is the point of intersection of 3 altitudes, means for this triangle BOC, we have to draw the 3 altitudes. Let's do so. Let's start from the vertex O. We know the altitude is the line segment that starts from the vertex and it is perpendicular to the opposite side. So this line segment will be the altitude from the vertex O. Got it? The altitude from the vertex B should be perpendicular to the side OC. So we can say this line segment is perpendicular to the extended side of OC. That is, this line segment is the altitude for this triangle. Similarly, the altitude from the vertex C will be perpendicular to the side BO. So we can say this line segment is the altitude from the vertex C, which is perpendicular to the extended side of BO. So we got the 3 altitudes for this triangle. Now we will locate the orthocenter. And we know orthocenter is the point of intersection of 3 altitudes. Let's extend all the altitudes. This point, that is point A, is the orthocenter for this triangle BOC. That is the point of intersection of these 3 altitudes. Got it? So A, that is the coordinate AP square, 2AP is the answer for this question. Got it? Let's move to the next question. The question is, what is the distance between the orthocenter and the circumcenter of a triangle whose sides measure 24 cm, 26 cm and 10 cm? Our first step, we will observe the question. In this question, a triangle is given whose 3 sides are given as 24, 26 and 10 cm. We have to find the distance between the orthocenter and the circumcenter for this triangle. If you remember our theory classes, we have studied the distance between incenter and the circumcenter. But we have not studied the distance between orthocenter and the circumcenter. There is no direct formula for the distance between the orthocenter and the circumcenter. So how to approach this question? What is the trick? The trick or the hint to approach the question is already given in the question. That is the three sides of the triangle. Let's see what is the hint. If you observe 24, 26 and 10 centimeter, that is the side of the triangle, are the Pythagoras triplet. The Pythagoras triplet means these three sides will form a right angle triangle. Let's check whether these are Pythagoras triplet or not. The longest of the three sides is 26 centimeter. That will be the hypotenuse for the triangle. So hypotenuse square is equal to the sum of square of the two legs of the triangle. Let's check. 26 square, it will be 676. And 24 square plus 10 square, it will be 676. So we got the hypotenuse square is equal to sum of square of two legs of the triangle. Okay, so these three sides are following the Pythagoras rule. So we can form a right angle triangle from these three sides. Let's do so. This is a triangle ABC with the side hypotenuse is 26 centimeter and the two legs of this triangle as 24 centimeter and 10 centimeter. Now we got a right angle triangle, and for this triangle we have to find the distance between orthocenter and the circumcenter. So firstly we will locate the orthocenter and the circumcenter. We know for a right angle triangle, orthocenter lie on the vertex of the triangle. Which vertex? The vertex which is having the 90-degree angle. So for this triangle ABC, the vertex B will be the orthocenter. And we also know for a right angle triangle, circumcenter lies on the midpoint of the hypotenuse. So let's locate the midpoint of the hypotenuse. So this point will be the circumcenter. So the midpoint of the hypotenuse will be the circumcenter for this triangle. So we have located the orthocenter and the circumcenter. If we forget that the orthocenter and the circumcenter lie at the vertex or the midpoint of the hypotenuse, then we will follow our simple fundamental. That is, we will locate the altitude for this triangle as well as we will locate the perpendicular bisectors. Then we can locate the orthocenter and the circumcenter. Let's also do the same so that any confusion can be removed. So first of all, we will locate the orthocenter, and we know orthocenter is the point of intersection of three altitudes. Means for this triangle we have to draw the three altitudes. And what is the altitude? Altitude is a line segment that starts from the vertex and it is perpendicular to the opposite side. So let's start from the vertex A. We have to draw the altitude from the vertex A, which is perpendicular to the side BC. So the side AB itself is the altitude from the vertex A. Okay, this side AB is the altitude from the vertex A. Similarly, if we have to draw the altitude from the vertex C, which is perpendicular to the side AB, then the side BC itself is the altitude from the vertex C. These two sides itself act as the altitude for this triangle ABC. Further, from the vertex B, we have to draw the altitude, which is perpendicular to the side AC. So this line segment will be the altitude for this triangle. And these three altitudes are intersecting at the vertex B. So we got the three altitudes for a triangle intersect at the vertex. And which vertex? The vertex which is having the 90-degree angle. So the vertex B is the orthocenter for this triangle ABC. Similarly, we will locate the circumcenter. We know circumcenter is the point of intersection of three perpendicular bisectors. Means for this triangle we have to draw the three perpendicular bisectors. The perpendicular bisector, we know it bisects the side of the triangle as well as it is perpendicular to the side of the triangle. So first of all, let's locate the midpoint of all the three sides. Okay, these 3 points are the midpoint of these three sides. From these 3 points, we have to draw the three line segments which are perpendicular to these three sides of the triangle. Let's draw the perpendicular bisector from the side AB. This is the perpendicular bisector. It is starting from the midpoint of AB and it is perpendicular to the side AB. Similarly, this line segment is the perpendicular bisector from the side BC. Further, from the side AC, this line segment is the perpendicular bisector. If you observe, all these three line segments are intersecting at the point O, that is the midpoint of the hypotenuse, that is side AC. So we got that the midpoint of the hypotenuse is the circumcenter for this triangle. Got it? This is the fundamental. So we got the orthocenter of the triangle lies at the point B, and the circumcenter for this triangle lies at the midpoint of the hypotenuse, that is AC. Let's come back to the question. In this question, we have to find the distance between orthocenter and circumcenter, that is, we have to locate this distance. Moving further, here point O is the midpoint of AC. So can we say BO is the median? We know median is a line segment that joins the vertex with the midpoint of the opposite side. So BO is the median. It is joining the vertex B with the midpoint of side AC, that is point O. Are you observing this question is involving multiple concepts? Such questions help in linking the fundamentals and building a strong foundation. And with the solution, we are also doing revision of many fundamentals. This question is very important and we will see 2 to 3 different approaches to solve the question. So moving further, we got BO as the median, or in other words, we can say BO is the median in a right angle triangle. So here, are you able to recall the fundamental that we have covered in the lecture of medians in a right angle triangle? The fundamental is that in a right angle triangle, median to the hypotenuse is half of the hypotenuse. So if we compare this with our figure, BO is the median and AC is the hypotenuse. So we got BO is equal to half of AC. That is, the median to the hypotenuse is equal to half of the hypotenuse. Here AC is 26 cm. So half of hypotenuse, that is half of AC, will be 13 cm. So we got BO as 13 cm. That is the distance between the orthocenter and the circumcenter is 13 cm. That is the answer of the question. Okay, this is the first approach that we have seen. Now we will see 2 more different approaches to solve the question. In this figure, are you able to visualize the 2 right angle triangle? These are the 2 right angle triangle. If we apply the Pythagoras in both of these triangles, we can get the distance between the orthocenter and the circumcenter. Let's take this triangle. Here we know this side will be the 12. Why? Because this point is the midpoint of the side AB. We have drawn the perpendicular bisector from the midpoint of this side. So we got this as 12, that is half of 24. Similarly, we got this side as half of BC, that is 10 by 2, that is 5 cm. Now we can easily apply the Pythagoras in this triangle and we can calculate the hypotenuse as 5 square plus 12 square, that will be root of 169, that is 13 cm. That is again the answer of our question. Okay, we got the answer as 13 cm with the help of the Pythagoras also. Moving further, if you observe the question, the point O is the circumcenter, and we know from the circumcenter we can form a circle which will touch the 3 vertex of the triangle. So from this point O, we can form a circle which is touching the side A, B and C. So this is the circumcircle. And by looking at the figure, we can say O is the center point and OA, OB and OC are the radius of this circle. OA and OC is given as 13 cm, that is half of the hypotenuse. So we got the radius of the circle as 13 cm and OB is also the radius of the circle. So we got OB as also equal to 13 cm. That is the answer of the question. Okay, we have used multiple fundamentals to solve this question. You should know each and every approach to solve the question. The question can come in different ways and you should know everything to tackle down the question. So this is an important question involving the fundamental of a right angle triangle, the fundamental of orthocenter and the fundamental of the circumcenter. So let's move to the next question. The next question is, refer the figure, triangle ABC is an equilateral triangle with side as 6 cm. 3 circles are drawn inside the triangle. Find the radius of these 3 circles. This question is very important question. It involves the fundamental of equilateral triangle as well as the fundamental of the incircles. Based on this concept, we will take 4 to 5 questions because these types of questions are generally asked in the competitive exam. In the end of this question, we will also do some tricks related to these equilateral triangles. So be with me and I need your full attention with this question. Let's begin with the question. We will go step by step. Our first step is we will observe and visualize the question. A triangle ABC is given and it is given as the triangle ABC is an equilateral triangle. With the side as 6 cm means all these 3 sides will be 6 cm. Further, 3 circles are given inside this triangle and we have to find the radius of these 3 circles. So first of all, we will try to recall the fundamental that we have done in the equilateral triangle. In the equilateral triangle, we have done many formulas. The 2 formulas that will be used in this concept are the height of the equilateral triangle, that is a root 3 upon 2, where a is the side of the triangle, and in radius that is equal to a root 3 upon 6. Here also a is the side of the triangle. These 2 formulas will build the base of the solution. Let's see how to approach the question. First of all, the side A is given as 6 cm. All the 3 sides are 6 cm. Let's try to calculate the height of the triangle. In the question, it is asked for the radius, but we will also calculate the height of the triangle because this height will be used to calculate the radius of the above 2 circles. So we got the height as a root 3 upon 2, where a is 6 cm. So we got the height as 3 root 3. Very simple, we have just applied the formula. So this distance is 3 root 3. Let's denote the point h1 at the base BC. So AH1 is equal to 3 root 3. Further, let's apply the formula of inradius, that is R1. Okay, we are denoting the inradius of this big triangle as R1. So we got R1 as a root 3 upon 6. Here a is 6 cm, that is the side of the equilateral triangle. So we got R1 as root 3. So we have got the height of this triangle ABC and we have got the inradius of this big circle. Let's denote the height of triangle ABC as h1 and side of the triangle as a1. In radius we have already denoted as r1. We are doing this to segregate the circles. Everything related to the big circle will be 1, that is a1, h1 and r1. And for the middle circle we will denote a2, h2 and r2. And for the smallest, that is the topmost circle, we will denote a3, h3 and r3. The biggest circle is 1, the middle circle is 2 and the smallest circle is 3. Further, we have done with the first circle. Let's move forward. In this figure, if we take O as the center of this big circle, we got the radius of this circle, that is OH1 as root 3. Root 3 is the radius of this circle. So this distance and this distance will be root 3. Let's mark the point H2 at the top of the circle. So we got H1, H2 as the diameter of the circle. That is root 3 plus root 3, that is the twice of radius, which is equal to 2 root 3. So we got the diameter of this big circle as 2 root 3. And this complete length, that is AH1, that is the height of the triangle, is 3 root 3. So can we say the balance length, that is AH2 as 3 root 3 minus 2 root 3, that is root 3. Okay, we got the distance AH2 as root 3. Let's draw a line DE which is parallel to the base BC. This line DE is parallel to BC. Here, are you able to observe the triangle ADE? Okay, this is the triangle ADE and this is the triangle ABC. Can we say both of these triangles are similar to each other? Are you able to observe? Here angle A is common in both the triangle, that is angle A in both the triangles are equal. And angle B is equal to angle D and angle C is equal to angle E. Why? Why these angles are equal? Because BC is parallel to DE and these angles are pair of corresponding angles. Remember the concept of the transversal line cut by the two parallel lines, the corresponding angles are equal. So these angles are equal to each other. So by the fundamental of similarities, we got both of these triangles are similar to each other. These two triangles are similar triangles. The triangle ABC is an equilateral triangle. So we can say the triangle ADE, that is this triangle, is also an equilateral triangle. Both the triangles are similar to each other. This is one of the important concepts. You should know it and you should remember it. Both of these triangles are similar to each other and both of these triangles are equilateral triangle. Moving further, if we take only this triangle ADE, here AH2, that is height of this triangle, is √3. The same we have just calculated. And we know the height of an equilateral triangle is a√3/2, where A is the side of this triangle. For this triangle, we will denote the side of the triangle as A2. All the three sides will be equal to A2. Further, on putting the value and solving, we got A2, that is side of the equilateral triangle ADE, as 2 cm. We got the side of this equilateral triangle. Now we can easily calculate the in radius, which is equal to a√3/6. Here we will denote the in radius of this circle as R2. Okay, we got R2 as a2√3/6. Here A2 is 2 cm. So we got R2 as 2√3/6, that is √3/3. So we got the in radius, height and side of this triangle ADE also. For the time being, we are not calculating the in radius of this small circle. We are developing a concept. If we observe the triangle ABC and the triangle ADE, the side of the triangle ABC is 6 cm and the side of the triangle ADE is 2 cm. And H1 is 3√3 and H2 is √3. And R1 is √3 and R2 is √3/3. Are you able to observe the ratio of A1 is to A2 is 3:1? Similarly, the ratio of H1 is to H2 is 3:1. And also the ratio of R1 is to R2 is 3:1. That is, the side, height and in radius of this smaller triangle is 1/3 of side, height and in radius of this bigger triangle. Are you able to observe everything of this smaller triangle is 1/3 of this bigger triangle? This is one of the important fundamental. The ratio of side, height and in radius of this small triangle is equal to 1/3 of the side, height and in radius of this big triangle. Got it? This is one of the important fundamental. If you know this fundamental, you can directly apply this concept and get the solution. The same fundamental we will try in this smaller circle. With the help of formula and the fundamental, we will calculate the side, height and in radius of this last circle. Then we will check whether this trick is applicable for this circle also. Let's see. First of all, let's try to calculate the height of this triangle. So again, we will draw a line segment FG which is parallel to DE. Here DE and FG are parallel to each other. The in radius of this middle triangle is √3/3. So we can say the diameter of this middle circle is 2 √3/3. Okay, that is the twice of the radius. And we know height of AH2, that is this complete length, is √3. So can we calculate the height of this small triangle, that is AH3, as √3 minus 2 √3/3? So we got the height of this topmost triangle as √3/3. We got the height. Further, DE and FG are parallel to each other. If we apply the same fundamental that we have applied for the big circle, we can say the triangle AFG is similar to triangle ADE. All the three angles of both the triangles are equal. The fundamental of corresponding angles and the transversals will be applicable. We got triangle AFG is similar to triangle ADE. So we can say triangle AFG is also an equilateral triangle. Got it? Let's try to calculate the side of this triangle AFC. We know the formula of height as a√3/2. Here let's denote the side of this triangle as A3, height as H3 and in radius as R3. Here H3 is equal to A3 √3/2 and we know H3 is equal to √3/3. On putting the value and solving, we got A3 as 2 upon 3. That is the side of this triangle AFC. Further, in radius, that is R3 is equal to A3 root 3 upon 6. On putting the values, we got R3 as root 3 upon 9. So we got A3, H3 and R3. Let's again compare this data with the data of the first and second triangle. Here also the same trick is applicable. That is, the side, height and in radius is 1/3 of the previous triangle, that is the below triangle. The side of first triangle is 6 and the side of the second triangle is 6 upon 3, that is 2, and the side of the third triangle is 2 upon 3. Okay, 1/3 of the previous value. Similarly, the height h1 of the first triangle is 3 root 3. The height of the second triangle is 1/3 of the 3 root 3, that is root 3, and the height of the third triangle is 1/3 of the h2, that is root 3 upon 3. Similarly, the r1 is root 3, so r2 is 1/3 of the r1, that is root 3 upon 3, and r3 is 1/3 of the r2, that is root 3 upon 9. We got in radius of all these three circles. That is the answer of the question. So in other words, we can say R1 is to R2 is to R3 is 1 is to 1 by 3 is to 1 by 9. One more observation that I want to add, this will help you in other questions. The observation is that here BC is parallel to DE is parallel to FG. Means these three line segments are parallel to each other. These three angles are corresponding angles under the parallel line, so these angles will be equal. And similarly, this angle will also be equal. That is, these three triangles are similar triangle. These three triangles are similar triangle, and triangle ABC is an equilateral triangle, means all these three triangles are equilateral triangle. This is an important fundamental. This fundamental can be used in solving questions. So this concept of similarity you should know. Moving further, so this is one of the important concept in the equilateral triangle. Based on this concept, we will take 4 to 5 questions. Let's move to the next question. The question is, in a given figure, ABC is an equilateral triangle. Two circles of radius 4 cm and 12 cm are inscribed in the triangle. What is the side of an equilateral triangle? 4 choices are given. So we will go step by step. Our first step is to observe and visualize the question. Here an equilateral triangle ABC is given and we have to calculate the side of this equilateral triangle. All the three sides will be equal. Two circles are given which are inscribed in this equilateral triangle, and the radius of the circles are given as 4 cm and 12 cm. In the equilateral triangle, we know the formula of in radius, that is r is equal to a root 3 upon 6. Here the in radius of this big triangle is given as 12 cm, so we can apply the formula, that is r is equal to a root 3 upon 6. Here r is 12. On putting the value, we got a, that is the side of an equilateral triangle, as 72 upon root 3. Let's multiply root 3 in numerator and denominator. We got the value of a as 24 root 3. Okay, that is the answer of the question. The above circle of radius 4 cm is given as an additional information. We don't require this information to calculate the side of this triangle. Sometimes additional information are given just to distract from the main fundamental. If you know the formula of in radius inside this circle, you can easily calculate the side of this triangle. So we got the side as 24 root 3. So the only fundamental that we use in this question is r is equal to a root 3 upon 6. Got it? Very simple and straightforward question. Let's move to the next question. Refer the below figure. The triangle ABC is an equilateral triangle. Find the radius of the circle and the side of the triangle. Our first step, we will observe the question. In this question, a triangle ABC as an equilateral triangle is given. One big circle and 3 small circles are given. The radius of these small circles are given as 4 units. This big circle is the inner circle as it is touching the three sides of the triangle. We have to calculate the in radius, that is the radius of the inner circle. Just now we have done the concept of circles inside the equilateral triangle, that is the ratio of radius will be equal to 1:3. If the radius of this above circle is 4 unit, can we say the radius of this big circle will be 3 times the radius of this circle? That is 4 into 3, that is 12 unit. So we got the in radius of this big circle as 12 unit. We have directly applied the trick that we have just seen. Now we got the r as 12 unit, that is the radius of the circle. Further, in the question we also have to calculate the side of this equilateral triangle. And we know the formula of in radius inside the equilateral triangle as r is equal to a root 3 upon 6. Here r is 12 unit. So on putting the value, we got a as 72 upon root 3. Let's multiply root 3 in numerator and denominator. We got the answer as 24 root 3, that is the side of an equilateral triangle. Got it? This is the answer. Okay, very easy. Got it? The fundamental that we have used is our trick, that is the ratio of r1 is to r2 is 1:3. Got it? And the second fundamental that we have used is the formula of in radius, that is r is equal to a root 3 upon 6. Got it? So let's move to the next question. Two circles are placed in an equilateral triangle as shown in the figure. What is the ratio of the area of the smallest circle to that of the equilateral triangle? 4 choices are given. First step, we will observe the question. Equilateral triangle is given and two circles are placed inside this equilateral triangle. And we have to calculate the ratio of the area of the smaller triangle, that is this triangle, to the ratio of this equilateral triangle. Let's approach the question. This is an equilateral triangle and we know the formula of radius of circles inside an equilateral triangle is r is equal to a root 3 upon 6. Let's denote the radius of this big circle as r1 and radius of this small circle as r2. And we have assumed a as the side of this triangle. All the three sides will be a. So r1 is equal to a root 3 upon 6. We have applied the direct formula. And we know r2 will be equal to 1/3 of the r1. Okay, we have applied the trick that we have just seen. So we got r2 is equal to r1 upon 3. And we know r1 is a root 3 upon 6. On putting the value and solving, we got r2 as a root 3 upon 18. Let's multiply root 3 in the numerator and the denominator. We got the value of r2 as a upon 6 root 3. In the question, we have to calculate the ratio of the areas. So firstly, let's calculate the area of this smaller circle. And we know area of the circle is pi r square. And for this smaller circle, the area will be pi r2 square. R2 is the radius of the circle. And we know r2 is equal to a upon 6 root 3. On putting the value, we got the area as pi a square upon 108. So we got the area of the small circle. Now we will calculate the area of this triangle. And we know the formula of the area of the equilateral triangle is a square root 3 upon 4. So we got the area of the smallest circle and the area of the triangle. Let's calculate the ratio. On solving, we got the ratio as pi is to 27 root 3. That is the answer of this question. So the fundamental that we have covered in this question are, the first fundamental that we have covered is the ratio of r1 is to r2 is 3:1. Then we have used the two formulas. The first formula is r is equal to a root 3 upon 6. Then we have used the formula of area of the triangle as a square root 3 upon 4. So these are the fundamentals that we have used in solving this question. Moving further, our next question is, there is an equilateral triangle with a square inscribed in it. One of the side of the square lies on the side of the equilateral triangle. What is the ratio of the area of the square to that of the equilateral triangle? 4 choices are given. Let's observe and visualize the question. Equilateral triangle is given. Let's take an equilateral triangle ABC. Inside this equilateral triangle ABC, a square is inscribed. And one side of the square is lying on the side of an equilateral triangle. This is a square, and we know all the four sides of a square are equal. Let's denote all the four sides as x unit. All these four sides will be x. Moving further, we also know the property of the square, that is opposite sides are parallel to each other. So here PQ will be parallel to RS, or we can say PQ is parallel to BC. These two sides are parallel to each other. If these two sides are parallel, can we say the triangle APQ is similar to triangle ABC? Here angle A is common in both the triangle, and angle B is equal to angle P, and angle C is equal to angle Q. Why? Because these angles are corresponding angles. And in the transversals we have done, the corresponding angles in case of parallel lines are equal. So both of these triangles, all the angles are equal, so we can say both the triangles are similar to each other. Both the triangles are similar to each other means the triangle APQ is also an equilateral triangle. And we know the three sides of an equilateral triangle are equal. Here PQ, that is the side of a square, is x. So we got all the three sides of this triangle as x unit. AP, AQ and PQ is equal to x. Moving further, in the question we have to calculate the ratio of the area of the square to that of the area of the triangle. Area of the square, it is equal to x square. Now we have to calculate the area of the triangle. And we know area of an equilateral triangle is equal to a square root 3 upon 4. So here we need to find the a, that is the side of the equilateral triangle, in term of x, so that we can calculate the ratio. Here we have to find the value of a in terms of x, means we have to find any of the one side of the triangle. Here if we take the side AC, which is equal to AQ plus QC, AQ we know it is equal to x. Somehow if we are able to find the QC, we can find the value of AC, that is the side of the triangle. So here we will focus to find the value of QC in term of x. I can directly proceed with the steps and answer to this question, but I am telling you how to approach the question. Here we have to calculate the ratio of the area of the square and the triangle. The ratio of the square we have calculated as x square. Now somehow we have to calculate the area of this triangle ABC in term of x. And we know the formula of area of the triangle as a square root 3 upon 4. So here somehow we have to convert the a into the x. Here a is the side of the triangle, and we have taken the side a as AC, that is this side, and we have taken AC as AQ and QC, and AQ we have calculated as x, and only now we have to calculate QC in term of x, so that our area of the triangle is converted into the x term. Are you getting the fundamental why we are proceeding in this way? So let's proceed. If we take the triangle QSC, here QS is equal to x and angle C is 60 degree. Why? Because ABC is an equilateral triangle and all the three angles of an equilateral triangle is 60 degree. Further, here angle S is 90 degree angle. Why? Because this is a square and square make angle of 90 degree at all the four vertex. So we got QSC as an right angle triangle. So we can apply the trigonometry, that is sine 60 degree is equal to perpendicular over hypotenuse. So we got sine 60 degree is equal to x upon QC. We know sine 60 degree is equal to root 3 by 2. On solving, we got QC is equal to 2x upon root 3. We got the value of QC. Means now we can calculate the value of AC, which is equal to AQ plus QC. On putting the value, we got AC is equal to x plus 2x upon root 3. And AC is equal to A, that is the side of the triangle. Now we can calculate the area of the triangle, that is equal to A square root 3 upon 4. On putting the value and solving, we got area of the triangle as 12 plus 7 root 3 upon 12 into x square. We have converted the area of the triangle in x term. And we know area of the square as x square. Now we can proceed for the ratio of the square and the equilateral triangle. On putting the value, we got the ratio as 12 is to 12 plus 7 root 3. This is the answer of the question. We got the answer, slightly a lengthy one. In this question, we have learned how to approach the question. I could have directly started with the steps to the solution, but I have chosen this way so you can learn how to analyze the question and how to approach the question. You can easily remember the formula, but analyzing the question and approaching to the solution is different. So again, my advice is on getting the question, just pause the video and try to solve the question on your own. You are already having the formula list. This technique will help you better analyze and approach the question. Now you will do the mistakes, but in the exam you will surely succeed in it. Let's move to next question. The question is, triangle ABC is an equilateral triangle and OB, OD and OC are the angle bisector. D, E and F are the midpoint of AO, BO and CO. O is the center of the circle in the given figure. Area of circle is 3 pi centimeter square. Find the length of AB. Let's observe the question. A equilateral triangle ABC is given. These three line segments are the angle bisector. And point D, E and F are the midpoint of AO, BO and CO. These are the midpoints, means AD will be equal to DO, BE is equal to EO and CF is equal to FO. In this question, we have to find the length of AB, means the side of the triangle. ABC is an equilateral triangle, so all the sides will be equal. So we can find any of the side. Moving further, the area of the circle is given as 3 pi centimeter square. And we know the area of the circle is pi r square. So we can write pi r square is equal to 3 pi. On solving, we got the radius of the circle as root 3. We got the radius of the circle, and note that this radius is not the in radius. We cannot apply the formula of in radius inside the equilateral triangle. This is a general circle inside the triangle. It is not touching any of the sides of the triangle. So it is only a small circle inside the triangle. And we got the radius of the circle as root 3. Radius means OD, OE and OF are the radius of the circle. So all these three line segments will be equal to root 3. And in the question it is given as D is the midpoint, means AD is equal to DO. So we got AD is also equal to root 3. And we got AO, that is this complete length, as AD plus DO, that is root 3 plus root 3 equal to 2 root 3. Okay, we got AO is equal to 2 root 3. Moving further, here in this question, AO is given as an angle bisector. Let's extend this angle bisector AO to meet the side BC of the triangle at point N. So we got AN as the angle bisector for this triangle. And point O is the incenter, that is the intersection point of three angle bisector. And we know inside an equilateral triangle, all the line segments as well as all the points of the circle are same. Means this angle bisector is also the median, and it is also the perpendicular bisector, as well as it is also the altitude for this triangle. And this point O is incenter, as well as centroid, as well as circumcenter, as well as orthocenter. All these line segments and this point is same. So we can say the point O is also the centroid for this triangle, and the angle bisector AN as the median for this triangle ABC. All are same. And we know the property of the centroid, that is the centroid divide the median into the ratio of 2:1. Means AO is to ON is equal to 2:1. And just now we have calculated AO as 2 root 3. So we got ON is equal to root 3. Okay, the ratio of AO is to ON is 2:1. AO is 2 root 3. So we got ON as root 3. Okay, the ratio will remain 2:1. Moving further, here AO is 2 root 3 and ON is root 3. So we can say length of AN as 2 root 3 plus root 3, that is 3 root 3. And AN is also the height of the triangle. And we know the formula of height inside an equilateral triangle is A root 3 upon 2. Okay, on putting the value and solving, we got A, that is the side of the triangle, as 6 centimeter. Okay, that is the answer of the question. Got it? So the fundamental that we have used are The first fundamental that we have used is inside an equilateral triangle, the angle bisector, median, perpendicular bisector and the altitude are same. And the point centroid, incenter, circumcenter and the orthocenter are also same. Then we have used the formula that the centroid divide the median into the ratio of 2:1. Then we have used the formula of height of an equilateral triangle, that is a root 3 upon 2. These are the fundamentals that we have used to solve this question. Let's move to next question. The question is, O and C are the orthocenter and the circumcenter of an acute angle triangle PQR respectively. The point P and O are joined and produced to meet the side QR at S. If angle QCR is equal to 130 degree and angle PQS is equal to 60 degree, then angle RPS is, 4 choices are given. Let's approach the question. Our first step, we will visualize and observe the question. In this question, a triangle PQR is given. Okay, let's take the triangle PQR. Point O and C are given as orthocenter and the circumcenter. Further, it is given that point P and O are joined and it is further extended to meet the side QR at the point S. Angle QCR is given as 130 degree, means the angle formed at the circumcenter is 130 degree. One angle of the triangle, that is angle PQS, is given as 60 degree. We have to find the angle RPS, means this angle. Let's proceed with the question. In this question, the point C is the circumcenter and angle 130 degree is the angle formed by the circumcenter. And we know the angle formed at the circumcenter is twice the opposite angle. So we got angle QCR is equal to twice of angle P. On putting the value, we got angle P as 65 degree. Okay, that is half of 130 degree. We got this complete angle as 65 degree. Further, if you observe, we know two angles of this triangle, that is angle P and angle Q. If we apply the sum angle property of the triangle, that is sum of three angles of a triangle is 180 degree, on putting the value and solving, we got angle R as 55 degree. This angle we got as 55 degree. Now we know all the three angles for this triangle, that is angle P, angle Q and angle R. Moving further, O is the orthocenter and we know orthocenter is the point of intersection of three altitudes. And what are altitudes? Altitudes are the line segment that start from the vertex and are perpendicular to the opposite side. So we can say PS is an altitude for this triangle. Why it is altitude? Because it is passing through the orthocenter O. If PS is the altitude, means this angle will be a 90 degree angle. We got angle PSR as 90 degree angle. If we observe the triangle PSR, that is this triangle, two angles for this triangle we know and third angle is missing. If we apply the sum angle property of the triangle, that is the sum of three angles of a triangle is 180 degree. On putting the value and solving, we got our missing angle as 35 degree. That is the answer of the question. Got it? So the fundamental that we have used in solve these questions are, the first fundamental that we have used is the angle formed at the circumcenter is twice the opposite angle. The second fundamental that we have used is the orthocenter. Orthocenter is the point of intersection of three altitude and altitude is a line segment that is perpendicular to the opposite side. So the fundamental of the altitude and the orthocenter we have used. Further, the sum angle property of the triangle we have used to finally solve this question. Got it? Let's move to the next question. The question is, in triangle ABC, AD is the median and in triangle ADB, BE is the median. If area of triangle BDE is 20 cm square, find the area of the triangle ABC. 4 choices are given. We will go step by step. Our step, we will observe and visualize the question. In the question, a triangle ABC is given. Okay, let's have a triangle ABC. AD is given as a median And we know what is median. Median is a line segment that joins the vertex with the midpoint of the opposite side. If AD is a median, means D will be the midpoint of the side BC. Further, for this triangle ABD, BE is given as a median. BE is a median, that is E will be the midpoint. Medians join with the midpoint of the opposite side. If BE is the median, then E will be the midpoint of the side AD. Area of the triangle BDE is given as 20 cm square. We have to find the area of this complete triangle ABC. Let's proceed with the question. If we observe the triangle ABD, only this triangle, here E is the midpoint of AD, means the ratio of AE is to ED will be equal to 1:1. Okay, E is the midpoint, both of these line segments will be equal to each other. Area of the triangle BED is given as 20 cm square. Can we say area of triangle BEA, that is area of this triangle, is also equal to 20 cm square? How? We have done the fundamental, that is the ratio of the area of two triangles having the same altitude is equal to their bases. If you observe, both of these triangles are having the same altitude. So we can say the ratio of area of both of these triangles will be equal to ratio of their bases. That is, ratio of area of triangle BED is to the area of triangle BEA is equal to 1:1. That is, ratio of DE is to EA. So area of both the triangles will be same, and area of triangle BDE is given as 20 cm square. So we got the area of triangle BEA as also equal to 20 cm square. So for this triangle ABD, we can say area of this complete triangle is equal to 20 plus 20, that is 40 cm square. Okay, so we got area of triangle ABD as 40 cm square. Further, for this triangle ABC, D is the midpoint. That is, the ratio of BD is to DC is equal to 1:1. We will apply the same fundamental for this triangle also. That is, the ratio of area of triangle ABD is to the area of triangle ACD is equal to BD is to DC, that is equal to 1:1. Means area of both of these triangles will be equal to each other. And just now we have calculated the area of triangle ABD as 40 cm square. So we got area of triangle ACD is also equal to 40 cm square. Let's add area of both the triangle. We got area of triangle ABC as 40 plus 40, that is 80 cm square. That is the answer of the question. Okay, got it? So the fundamental that we have used in solving this question is the fundamental of the median. That is, median joined with the midpoint of the opposite side. That is, it divides the opposite side into the ratio of 1:1. Further, the second fundamental that we have used is the ratio of the area of two triangles having the same height or the altitude is equal to ratio of their bases. Got it? Let's move to the next question. The question is, ABC is a right angle triangle, angle B is 90 degree and BD is the median. O is the centroid of the triangle. Find the length of OB if AB is 9 cm and AC is 41 cm. Four choices are given. Okay, our first step, we will observe and visualize the question. In this question, a right angle triangle ABC is given, okay, which is having a 90 degree angle at angle B. For this triangle ABC, BD is given as a median. If BD is a median, then D will be the midpoint, that is AD will be equal to DC. Further, in the question, the length of AB is given as 9 cm and the length of AC is given as 41 cm. If the length of AC is 41 cm and D is the midpoint, so can we say AD and DC will be equal to 41/2? D is the midpoint and AD is equal to DC. We have divided 41 cm into two parts. Further, in this question, we have to find the length of OB. Here O is the centroid for this triangle. And what is centroid? Centroid is the intersection point of three medians. Here O is the centroid and we have to find the length OB. Further, we have covered the concept in the lecture of medians in a right angle triangle. We know that in a right angle triangle, the median to the hypotenuse is equal to half of the hypotenuse. Here AC is the hypotenuse and BD is the median to the hypotenuse. So we can say BD will be equal to half of AC. Okay, we have applied the fundamental. The median to the hypotenuse is equal to half of the hypotenuse. And half of the hypotenuse is 41 upon 2. 41 centimeter is the hypotenuse. So we got BD is equal to 41 upon 2. Further, in the question, we have to calculate the length of OB. O is a centroid, and we know the centroid divide the median into the ratio of 2:1. So we can say BO is to OD will be equal to 2:1. And we have calculated the length of BD as 41 upon 2. So can we say BO is equal to 2 by 3 into BD? The ratio of BO is to OD is 2:1. On putting the value and solving, we got the answer as 41 upon 3, that is the length of BO. That is the answer of the question. Got it? So the fundamental that we have used in solving these questions are, the first fundamental that we have used is, in a right angle triangle, the median to the hypotenuse is equal to half of the hypotenuse. The second fundamental we have used is the centroid divide the median into the ratio of 2:1. So these fundamentals we have used to solve the question. Okay, let's move to the next question. The question is, refer the figure. O is the circumcenter for triangle ABC. Find the missing angle X and Y. Let's refer the figure. In this figure, a triangle ABC is given and point O is given as circumcenter. For this triangle ABC, we have to find the missing angle X and Y. Let's proceed with the question. By looking at the figure, can we say angle BOC is the angle formed at the circumcenter? O is given as the circumcenter, and we know the formula of angle formed at circumcenter is equal to twice the opposite angle. That is, angle BOC is equal to twice the angle A. And angle A is given as 55 degree. On putting the value, we got angle BOC as 110 degree. Okay, we got the angle BOC. Moving further, here O is the circumcenter. And we know from the circumcenter, we can form a circle which is touching the three vertex of the triangle. Means from this point O, we can form a circle which is touching the point A, B and C. This is the circumcircle. And OA, OB and OC are the radius of the circumcircle. And the radius of a circle is fixed, that is OA, OB and OC will be equal to each other. These three line segments will be equal to each other. This is one of the important fundamental, that is the distance of circumcenter to each vertex of a triangle is equal. So all these three line segments will be equal to each other. Further, if we take the triangle OBC, this small triangle, here OB is equal to OC. And this angle we have calculated as 110 degree. Here OB is equal to OC, so can we say this triangle is an isosceles triangle? Okay, two sides of these triangles are equal. And we know the angle opposite to equal sides in a triangle is equal. So the angle opposite to these two equal sides, that is angle X and angle Y, will be equal to each other. Got it? This triangle is an isosceles triangle. Two angles of this triangle is equal, and third angle we have calculated as 110 degree. Now we can easily apply the sum angle property of the triangle. That is, the sum of three angles of a triangle is 180 degree. On putting the value and solving, we got angle X and Y as 35 degree. That is the answer of the question. Got it? So the fundamental that we have used in solving this question is, the first fundamental we have used is the angle formed at the circumcenter is twice the opposite angle. The second fundamental we have used is the circumcenter is equidistant from all the three vertex of the triangle. That is, for the circumcenter, OA, OB and OC will be equal to each other. The third fundamental we have used is, for an isosceles triangle, the angles opposite to equal sides are equal. And lastly, we have used the sum angle property of the triangle. That is, the sum of three angles of a triangle is equal to 180 degree. So let's move to the next question. Refer the figure. O and H are the circumcenter and the orthocenter for the triangle ABC. Find the missing angle theta. Let's refer the figure. In this figure, triangle ABC is given and H is the orthocenter and O is the circumcenter. This angle is given as 20 degree. We have to find the missing angle theta, that is this angle. Let's proceed with the question. So firstly, let's join point B and C with point O. Here O is the circumcenter and we know the circumcenter is equidistant from the vertex of the triangle. That is OA, OB and OC will be the circumradius and these three line segments will be equal to each other. If we observe the triangle AOC, these two sides are equal to each other. That is, this triangle is an isosceles triangle. Similarly, this triangle is also an isosceles triangle and this triangle is also an isosceles triangle. And we know in an isosceles triangle, the angles opposite to equal sides are equal. So if we talk about the triangle AOC, these two angles will be equal to each other. Why? Because these two angles are opposite to these two equal sides. These two sides are equal, so these two opposite angles will be equal to each other. So we got this angle as also equal to 20 degree. Similarly, for this triangle BOC, these two angles will be equal to each other. Let's give name to both of these angles as angle X. Further, for this triangle AOB, these two angles will be equal to each other. Let's assume both of these angles as angle Y. Moving further, for this triangle ABC, we know the sum angle property of the triangle, that is sum of three angles of a triangle is equal to 180 degree. So angle A plus angle B plus angle C will be equal to 180 degree. Here angle A is Y plus 20 degree and angle B is X plus Y, angle C is X plus 20 degree. On putting the value and solving, we got angle X plus Y is equal to 70 degree. Got it? Moving further, here H is given as the orthocenter. And what is orthocenter? Orthocenter is the point of intersection of three altitudes. If H is the orthocenter, can we say AH is the altitude for this triangle? Let's extend the altitude to meet the side BC. Okay, we got AD as the altitude for this triangle. And we know altitude is perpendicular to the opposite side, that is this angle will be equal to 90 degree angle. Further, if we observe the triangle ABD, that is this triangle, okay, this is a right angle triangle, this angle is 90 degree angle and this angle is angle X plus Y and this angle is angle theta that we have to calculate. And just now we have seen angle X plus Y is equal to 70 degree. Okay, this angle is 70 degree, this angle is 90 degree and this is angle theta. Let's apply the sum angle property of the triangle. On putting the value and solving, we got angle theta as 20 degree. That is the answer of the question. Got it? So the fundamental that we have used in solving this question is, the first fundamental that we have used is the circumcenter is at equidistance from the three vertex of the triangle, that is OA, OB and OC are the circumradius and these three line segments are equal to each other. The second fundamental that we have used is, in an isosceles triangle, the angle opposite to the equal sides are equal. The third fundamental we have used is the orthocenter and the altitude. And the last fundamental we have used is the sum angle property of the triangle. Got it? One interesting thing that we observe in this question is, this can be an observing point for your further questions. For a triangle ABC, if O is a circumcenter, then OA, OB and OC will be equal to each other. Why? Because the circumcenter is at equidistance from the three vertex of the triangle and OA, OB and OC are the circumradius. Further, the observation is that by joining the circumcenter with the three vertex, we got three triangles. And all these three triangles are isosceles triangle. And in the isosceles triangle, we know the angle opposite to equal sides are equal. It means that these angles and these angles and these angles will be equal to each other. This you can add as an observation point, and this trick you can directly apply into the question. Got it? A small observation that can be helpful to you in the mid of the examination. Let's move to the next question. The question is, refer the figure. In a triangle ABC, H is the orthocenter, O is the circumcenter, AH is 2 cm. Find OD. Let's observe the figure. ABC is given as a triangle. H is the orthocenter and O is the circumcenter. This line segment AH is given as 2 cm. We have to find this line segment OD. Let's approach the question. How to approach this question? For that, we have to go back to the fundamental of the Euler line. Do you remember in the Euler lines, we have done the fundamental, that is HG is to GO is equal to 2:1. Do you remember that? During the proof of that fundamental, we have proved that both of these triangles are similar to each other. The same fundamental will be used to solve this question. Okay, that I will tell you how to approach this question. The point to be noted is that doing the proof is very important, because in mid of the proof you got some concept that you can apply in solving the question. So doing the proof will help you a lot in solving many questions. Let's see how to approach this question. Let's join point O and point H. Are you able to observe OH is an Euler line? Okay, we have done the concept, that is the Euler line passes through the circumcenter, centroid and the orthocenter. So OH is an Euler line. It means that point G, that is the centroid, will be somewhere on this line. Okay, the point O, G and H lies on the Euler line. So the point G must be between the point O and point H on this line. Let's try to locate the point G. Before that, we know O is the orthocenter, means OD is the perpendicular bisector. And we know the perpendicular bisector bisect the sides of the triangle. It means it is dividing the side BC into two equal parts. That is, D is the midpoint of side BC. We got D as the midpoint of side BC. Let's join A with D. AD is a line segment that is joining the vertex with the midpoint of the opposite side. And what is the line segment that joins with the midpoint of the opposite side? It is median. So we got AD is a median. And we know the median passes through the centroid, or the centroid is the intersection point of the three medians. So we got the centroid, that is the point G, at this point. The centroid lies on the median, as well as the centroids lies on the Euler line. So this point will be point G. In the proof of the Euler lines, we have proved that both of these triangles are similar to each other. Here AG is to GD will be equal to 2:1. Why? Because the centroid divides the median into the ratio of 2:1. And we know HG is to GO is equal to 2:1. The ratio is 2:1. We have proved in the Euler line. So we got both of these triangles are similar to each other and the ratio of the sides is 2:1. So we got the ratio of AH is to OD will be equal to 2:1. AH is given as 2 cm, so we got OD as 1 cm. Got it? Very simple question. It just involves the small fundamentals of the Euler line. That is, both of these triangles are similar to each other. And the second fundamental is that the centroid divide the median into the ratio of 2:1 and the ratio of HG is to GO is 2:1. So based on these small fundamentals, we have solved this question. Got it? Let's move to the next question. The question is, refer the figure. ABC is a right angle triangle and AC is equal to 100 cm. Also, AD is equal to DE is equal to EF is equal to FC. Find the value of BD square plus BE square plus BF square in centimeter square. 4 choices are given. Okay, we will go step by step. Our first step, we will observe the question. Let's refer the figure. In this figure, a right angle triangle ABC is given. This is the triangle ABC. It is having a right angle at angle B. Further, AC, that is the hypotenuse for this triangle, is given as 100 cm. Okay, this complete length is 100 cm. Further, AD, DE, EF and FC are equal to each other. These four line segments are equal to each other. If this total length is 100 cm, can we say all these four segments are equal to 25 cm? 100 upon 4, all these line segments are equal to each other. Further, if we only observe this triangle ABC, can we say E is the midpoint of the side AC, or can we say E is the midpoint of the side hypotenuse? AC is the hypotenuse. So can we say BE is the median for this right angle triangle ABC? Are you able to correlate this fundamental with the fundamental of the medians in the right angle triangle? There we have studied that median to the hypotenuse is equal to half of the hypotenuse. So B is the median to the hypotenuse and AC is the hypotenuse. So can we say BE is equal to half of AC, and we know AC is 100 cm. So we got the value of BE as 50 cm. Got it? We have used the fundamental of the median in a right angle triangle. That is, the median to the hypotenuse is equal to half of the hypotenuse. Got it? Moving further, in this question we have to calculate the value of BD square plus BE square plus BF square. That is sum of these three line segments. Let's see how we approach this question. Are you able to observe the triangle ABE and the triangle BEC? These two triangles. Let's segregate both the triangle and rotate these triangles. AE and EC are the base of both these triangles. And are you able to observe point D is the midpoint of AE and point F is the midpoint of EC? So can we say BD is the median for the first triangle and BF is the median for the second triangle? ED and BE are the median for both the triangle. Further, in the question we have to calculate the sum of square of these three line segments, that is BD square plus BE square plus BF square. Are you able to remember any concept or the formula which involves the length of the sides of the triangle and the length of the median? Do you remember any of the formula? The formula that I am talking about is the Apollonius theorem. Okay, do you remember? This is the Apollonius theorem that we have covered in the median. Here A square plus B square is equal to twice of AD square plus C by 2 square. Here A and B are these two sides and AD is the median between the side A and B. And C is the opposite side or the remaining side. A square plus B square is equal to twice of AD square, that is square of the median, plus C by 2 square, that is square of half of the opposite side. C by 2 is the half of the opposite side. Let's apply the same Apollonius theorem to our two triangles. Let's apply in our first triangle. Here BD is the median and BE and BA are the two adjacent sides to this median. Or we can say BD is the median between the side BE and BA. And A is the opposite side, that is AE by 2 will be applicable. So we got the formula AB square plus BE square is equal to twice of BD square plus AE by 2 square. Here BE is 50 cm that we have calculated and AE, that is the opposite side, is 50. So on putting the value, so we got AB square plus 50 square is equal to 2 times BD square plus 25 square. Let's give the name to this equation as 1, that is, this is our first equation. Let's apply the Apollonius theorem in the second triangle. We got BC square plus BE square, sum of square of these two sides. It is equal to twice of median square, that is BF square, plus half of the opposite side, that is EC by 2 square. On putting the value, we got BC square plus 50 square is equal to twice of BF square plus 25 square. Okay, this is our second equation. If you observe in both of these equations, the missing terms are AB square, BD square, BC square and BF square. Here we are able to find BD square plus BF square. And in the question we have to find BD square plus BE square plus BF square. BD square and BF square, these two terms are coming in both of this equation. So let's proceed. Let's add both of this equation. On adding, we got this equation. Here, if you observe, AB square and BC square are these two sides of the main triangle. And our main triangle, that is triangle ABC, is an right angle triangle. So applying the Pythagoras, can we say AB square plus BC square is equal to AC square? AC is the hypotenuse. And in the question, it is given as AC is equal to 100 centimeter. Okay, so AC square is equal to 100 square. Let's put the value. We got our this equation. On solving, we got the answer as 6250. We got the value of BD square plus BF square. But in the question, we have to calculate the value of BD square plus BE square plus BF square. Means we have to add the value of BE square to our equation, and we have calculated BE as 50 centimeter. Let's add BE square, that is 50 square. On adding, we got our answer as 8750. That is the answer of the question. So the fundamental, okay, two main fundamentals we have used. The first fundamental that we have used is, in a right angle triangle, the median to the hypotenuse is equal to half the hypotenuse. And the second fundamental that we have used is the Apollonius theorem, that is A square plus B square is equal to twice of AD square plus C by 2 square. These two major fundamentals we have used to solve the question. Let's move to the next question. The question is, in triangle ABC, D is the midpoint of side BC, E is the midpoint of AD, F is the midpoint of BE, and G is the midpoint of FC. What part of the area of triangle ABC is area of triangle EFG? Our first step, we will observe the question. In this question, a triangle ABC is given. So let's draw a triangle ABC. D is given as the midpoint of BC. Further, it is given as E is the midpoint of AD. So let's draw the line segment AD. Okay, this is the line segment AD, and E is the midpoint of AD. Okay, we have located the point E as the midpoint of AD. Means AE is equal to ED. That is, both of these line segments will be equal to each other. Further, it is given as F is the midpoint of BE. Let's draw the line segment BE, and we will locate the point F, which is the midpoint of BE. Means BF will be equal to FE. Okay, F is the midpoint. Further, it is given as G is the midpoint of FC. So let's join point C with F. We got FC. And it is given G as the midpoint of FC. Let's locate the point G. G is the midpoint of FC, means both of these line segments, that is FG and GC, will be equal to each other. And the question is asking about what part of area of triangle ABC is the area of triangle EFG. Here EFG is this small triangle. We have to calculate the area of this triangle EFG in terms of ABC. Let's proceed with the question. For that, let's assume the area of the triangle ABC as 1 unit. We have assumed the area of the triangle ABC as 1 unit, and we have to calculate the area of the triangle EFG in terms of ABC. Let's see. Now how to approach this question. The only and only one fundamental will be applicable in solving this question. The fundamental is that the ratio of area of two triangles having the same height is equal to ratio of their bases. Based on this single fundamental, we will solve the question. Let's see how this fundamental is applicable. Let's join E to C. We have joined E to C. So first of all, let's take the triangle ABC. For this triangle ABC, D is the midpoint of side BC. Means the ratio of BD is to DC is equal to 1:1. And this triangle ABC is composed of two triangles, triangle ABD and triangle ACD. And just now we have seen the fundamental, that is the ratio of area of two triangles having the same height is equal to ratio of their bases. Okay, the same case will be applicable here also. So we got the ratio of area of triangle ABD is to the area of triangle ACD is equal to BD is to DC. And we have got BD is to DC is equal to 1:1. That is, ratio of area of both of this triangle will be 1:1. We have assumed the area of the complete triangle as 1 unit. And area of both of this triangle are equal. So can we say area of triangle ABD and area of triangle ACD is equal to half unit? Okay, we have divided the 1 unit into 2 equal parts, that is half and half. Area of both of the triangle will be half unit. Got it? Moving further, if we divide this figure into two parts, are you able to observe the triangle ABD? This triangle ABD is composed of two triangles, the triangle DBE and triangle EBA. Here E is the midpoint of the side AD, so the same fundamental will be applicable. If E is the midpoint of AD, can we say DE is to EA is 1:1? So the same fundamental will be applicable. That is, ratio of area of triangle DBE is to area of triangle EBA is equal to DE is to EA. That will be 1:1. Means area of both of these triangles will be equal to each other. And just now we have seen the area of triangle ABD is half unit. Okay, we have assumed area of complete triangle as 1 unit and area of triangle ABD as half unit. And further, we have to divide this half unit into two equal parts. So we got area of both of this triangle as 1/4 unit. We have divided the half unit into two parts, that is 1/4 and 1/4. Similarly, if we observe the triangle ADC, same fundamental will be applicable. Here is the midpoint of AD, that is AE is equal to ED. So we got area of both of this triangle will be equal to each other, that is ratio will be 1:1. And area of this complete triangle is half unit. So we got area of both of this triangle as 1/4 unit. Got it? Moving further, area of this triangle is 1/4 unit and area of this triangle is 1/4 unit. If we add both of this triangle, can we say area of this complete triangle, that is triangle EBC, is equal to half unit? We have added 1/4 plus 1/4, that will be 1/2. So we got area of this complete triangle as half unit. Moving further, this triangle is also composed of these two triangles. F is the midpoint of BE, so ratio of BF is to FE will be 1:1. So we got ratio of area of both of these triangle will be 1:1. And just now we have calculated the area of this complete triangle as half unit. So we got area of both of this triangle as 1/4 and 1/4 unit. Got it? Moving further, if we observe the triangle EFC, that is this triangle, here G is the midpoint of FC. If G is the midpoint of FC, can we say FG is to GC is 1:1? The same fundamental will be applicable here also. That is, the ratio of area of both of this triangle is 1:1. And just now we have calculated the area of this complete triangle as 1/4 unit. So we have to divide 1/4 into two parts, that is 1/8 and 1/8. So we got area of triangle EFG as 1/8 unit. Initially, we have assumed area of triangle ABC as 1 unit and we got area of triangle EFG as 1/8 unit. Means the area of triangle EFG is equal to 1/8 of the area of triangle ABC. That is the answer of the question. Got it? So the only fundamental that we have used in solving this question is the ratio of area of two triangles having the same height is equal to ratio of their bases. Based on this fundamental, we have solved this question. Let's move to the next question. The question is, find the altitude to side AC of triangle with side AB is 20 cm, AC is 20 cm and BC is 30 cm. Okay, let's proceed with the question. In this question, three sides of a triangle are given as AB, AC and BC. Means we have to assume a triangle ABC. AB is given as 20 cm, AC is given as 20 cm and BC is given as 30 cm. Here AB and AC both are given as 20 cm, means this triangle ABC is an isosceles triangle. Got it? Further, in this question we have to find the altitude to the side AC. And we know what is altitude. Altitude is a line segment that starts from the vertex and it is perpendicular to the opposite side. And we have to calculate the length of the altitude to the side AC. Means we have to calculate the length of this line segment, that is BE. Okay, BE is perpendicular to AC. Moving further, let's locate the midpoint of BC as point D. Point D is the midpoint of BC. Let's join A to D. Here AD is the median to the triangle ABC. Okay, what is median? Median is a line segment that starts from the vertex and joins the midpoint of the opposite side. Here this line segment is starting from the point A and it is joining the point D, that is the midpoint of side BC. So we got AD as the median for this triangle. Further, can we say this line segment AD is also the altitude for this triangle? Let's see how. Here this triangle ABC is an isosceles triangle. That is AB is equal to AC. Okay, both of these line segments are 20 cm. Further, we know in a isosceles triangle, the angle opposite to the equal sides are equal. Means these two angles will be equal to each other. Further, D is the midpoint, means BD will be equal to DC. So by SAS rule, can we say both of these triangles are congruent triangle? We got both of these triangles are congruent triangle. So by CPCT, can we say angle ADB is equal to angle ADC? And BC is a straight line, means sum of both of these angles will be equal to 180 degree. We have applied the linear pair axiom. So we got both of these angles is equal to 90 degree. Both of these angles are equal and sum of both of these angle is 180 degree. It means that the line segment AD is also the altitude for this triangle. AD is the median and AD is also the altitude for this triangle. Moving further, if we only take the triangle ABD, okay, ABD is a right angle triangle, angle D is 90 degree angle. For this triangle ABD, AB is the hypotenuse. So can we apply the Pythagoras? We got AB square is equal to AD square plus BD square. That is 20 square is equal to AD square plus 15 square. On solving, we got the value of AD as 5√7. So with the help of AD, that is the height or the altitude for this triangle, and with BC as a base, can we calculate the area of this triangle? We got area of this triangle ABC as half into base into height, that is half into BC into AD. Okay, we have considered BC as base and AD as the height for this triangle. On solving, we got the area of the triangle ABC. Further, we can also calculate the area of the same triangle ABC by considering AC as a base. If we consider AC as a base, then the respective height of the triangle will be BE. That is, the area of the triangle ABC is equal to half into AC into BE. And we know AC as 12 cm, and we have just calculated the area of the triangle. On putting the value and solving, we got BE, that is the altitude to the side AC, as 15√7/2. That is the answer of the question. So the first fundamental or the concept that we have used is, in an isosceles triangle, AD is median as well as AD is the altitude for this triangle. And this line segment divides the triangle into two congruent triangles. And the second fundamental that we have used is the area of the triangle is half into base into altitude. So based on these basic fundamentals, we have solved the question. Let's move to the next question. The question is, consider a right angle triangle with in radius 2 cm and circumradius of 7 cm. What is the area of the triangle? Okay, let's proceed with the question. In this question, we have to consider a right angle triangle. Let's have a right angle triangle ABC, which is having a 90 degree angle at B. In this question, in radius for this triangle ABC is given as 2 cm. Let's denote the in radius as small r, which is equal to 2 cm, and the circumradius, that is capital R, is given as 7 cm. And in this question, we have to find the area of the triangle ABC. Let's see how to approach the question. In radius and circumradius are given in this question. And we know the formula of in radius is area of the triangle upon semiperimeter. In radius is given as 2 cm. We have to calculate the area of the triangle. Somehow, if we are able to calculate this S, that is the semiperimeter, we will be able to solve this question. And we know semiperimeter is A plus B plus C upon 2. That is half of the perimeter of the triangle. Means we have to calculate the three sides of the triangle to calculate the semiperimeter. And none of the three sides are given. We have to find a way to solve the three sides of the triangle. Moving further, the circumradius is given as 7 centimeter. And we know what is circumradius. Circumradius is the radius of the circumcircle. And what is circumcircle? Circumcircle is a circle which is touching the three vertex of the triangle. And we know the center point of the circumcircle is the circumcenter. And we also know for a right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. This is the concept that we have done. That is, for a right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. Let's mark the midpoint of the AC, say point D. Point D, that is the midpoint of AC, that is the hypotenuse, is the circumcenter. Okay, this is circumcenter and this is circumcircle. And in the question, the circumradius is given as 7 centimeter. Means AD and DC will be equal to 7 centimeter. Okay, D is the midpoint, that is the circumcenter, and AD and DC will be the circumradius. So we got AD and DC is equal to 7 centimeter. So we got AC is equal to 7 plus 7, that is 14 centimeter. Okay, we are able to find one side of this triangle. Now we have to find the other two sides of the triangle. Let's proceed. Let's draw incircle for this triangle. We know incircle is a circle which is touching the three sides of the triangle. Okay, this is incircle and this is in radius. Further, we know the property of the incircle, that is the sides of the triangle act as tangent to the incircle. So these three sides of the triangle are acting as an tangent to this incircle. Further, now the tangents are coming into the picture, and we know the property of the tangent. The tangent from any external point toward the circles are equal. So if we take A as an external point, these two line segments will be the tangent to the circle and these two line segments will be equal to each other. Okay, let's denote this point as E. So we got AE is equal to AD. And we know AD is 7 centimeter. So we got AE as also equal to 7 centimeter. Similarly, if we take C as an external point and these two line segments as tangent to the circle, let's denote this point as point F. So can we say CD is equal to CF? C is the external point and these two line segments are tangent which are equal to each other. And we know CD is 7 centimeter. So we got CF as also equal to 7 centimeter. Further, the radius and the sides of the triangle are perpendicular to each other. Why they are perpendicular? Because the radius and tangent makes the angle of 90 degree with each other. So the radius, that is the in radius, and the sides of the triangle, that is the tangents, will be perpendicular to each other. So this angle will be 90 degree angle. Further, ABC is a right angle triangle, that is angle B is 90 degree. So these two line segment and these two line segment will be parallel to each other. If this line segment is 2 centimeter, then this will be 2 centimeter. And if this line segment is 2 centimeter, then this line segment will also be 2 centimeter. If you observe, we got the complete length of AB as 7 plus 2, that is 9 centimeter. And the complete length of BC will be 7 plus 2, that is 9 centimeter. Now we got the three sides of the triangle. Now we can easily calculate the semi-perimeter. That is A plus B plus C upon 2. That will be 9 plus 9 plus 14 upon 2. So we got the semi-perimeter S as 16 centimeter. Now we can easily apply our formula, that is in radius is equal to area of the triangle upon semi-perimeter. On putting the value and solving, we got area of the triangle as 32 centimeter square. Okay, that is the answer of the question. Okay, so the fundamental that we have used in solving this question is, the first fundamental that we have used is the formula of in radius, that is in radius is equal to area of the triangle upon semi-perimeter. The second fundamental that we have used is, for a right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. The next fundamental that we have used is, the half of the hypotenuse is equal to the circumradius. The next fundamental that we have used is, the sides of the triangle act as tangent to the incircle. The next fundamental that we have used is, the tangents from any external point toward a circle are equal to each other. Further, we have used the fundamental that is the in radius is perpendicular to the sides of the triangle. So based on this fundamental, we have solved the question. So we have used many fundamentals, and this is very important question because it involves multiple fundamental. Okay, and such type of question basically enhance your basic fundamental. So let's move to the next question. Refer the figure. Perimeter of the triangle ABC is 25 centimeter. Find the area of the circle. Our first step, we will observe and visualize the question. Let's refer the figure. In this figure, a triangle ABC is given. The three angles of this triangle are given as 30 degree, 30 degree and 120 degree. Let's assume the three sides as A, B and C. The side opposite to angle A is A, and the side opposite to angle B is B, and the side opposite to angle C is C. Further, here angle A and angle B for this triangle are equal, that is both are equal to 30 degree. And we know the side opposite to equal angles in a triangle are equal. Means the side A and side B will be equal to each other. Why? Because these two sides are opposite to these two equal angles. Got it? Further, the perimeter of the triangle is given as 25 centimeter. That is A plus B plus C is given as 25 centimeter. A circle is given which is touching the three vertex of the triangle. And we know the circle which is touching the three vertex of the triangle is a circumcircle. And we have to find the area of the circle. And we know the area of the circle is pi r square. If somehow we are able to find the radius of the circle, that is, if somehow we are able to find the circumradius, we can find the area of the circle. Moving further, and we know the relation between the sides of the triangle and the circumradius as A upon sin A is equal to B upon sin B is equal to C upon sin C is equal to 2r. Here capital R is the circumradius. Okay, we have to calculate this capital R to find the area of the circle. If we are able to find any of the one side of this triangle, we can use any of this relation to find the circumradius. As we know all the three angles, that is angle A, angle B and angle C. So now our focus is to find any of the side of this triangle. Let's proceed. Here A plus B plus C, that is the sum of three sides of the triangle, is given as 25 cm. Here A is equal to B. So we got 2A plus C is equal to 25. On solving for C, we got C as 25 minus 2A. We got the value of C in term of A. Moving further, if we take these two relations, that is A upon sin A is equal to C upon sin C, we know angle A is 30 degree and angle C is 120 degree. We know the value of sin 30 is 1 by 2. And we know the value of sin 120 degree is sin 90 plus 30, which is equal to cos theta. So sin 90 plus 30 will be equal to cos 30 degree. 90 plus 30, it is coming in the second quadrant, and we know in the second quadrant sin is positive. Okay, we have covered the same in very detail in our trigonometry lecture. So we got sin 120 degree is equal to cos 30 degree, which is equal to root 3 by 2. Let's put the value. On putting the value and solving, we got C is A root 3. We got the value of C in terms of A. Further, we have done the relation, that is C is equal to 25 minus 2A. Let's put the value of C as A root 3 in this equation. On solving, we got the value of A as 25 upon 2 plus root 3. And we know root 3 is 1.732. On putting the value and solving, we got A as 6.7 centimeter. We got A, that is one side of this triangle, as 6.7 centimeter. Moving further, we got the one side. Now we have to calculate the circumradius, that is the capital R. If we take these two relations, that is A upon sin A is equal to 2R. Here we know the value of side A and angle A. Let's put the value. On solving, we got the circumradius, that is capital R is 6.7 centimeter. Further, we have to calculate the area of the circle. And we know area of the circle is pi r square. And just now we have calculated capital R as 6.7 centimeter. On putting the value and solving, we got area of the circle as 140.9 centimeter square. This is the answer of the question. Got it? So the fundamental that we have used in solving these questions are, the first fundamental we have used is our relation, that is A upon sin A is equal to B upon sin B is equal to C upon sin C is equal to 2R. The second fundamental that we have used is the sides opposite to equal angles are equal. So based on these fundamentals, we have solved the question. Let's move to the next question. The question is, John is standing on a side AB of a triangle ABC with sides 4 cm, 5 cm and 6 cm. John jumps on side BC and then jumps on side CA and finally comes back to its original position. The smallest distance that John could have jumped is, let's go step by step. Our first step is to visualize and observe the question. In this question, a triangle ABC is given. Let's have a triangle ABC and the three sides of this triangle are 4 cm, 5 cm and 6 cm. Further, a person John is given which is standing on the side AB. Let's say John is standing at the point D. Then the John jumps to the side BC. Let's assume the John jumps to the point E. The point E is on the side BC. Further, John jumps from the side BC to AC. Let's assume the point F on the side AC where the John has jumped. Further, the John has jumped from the side AC to the side AB, that is to its original position. So basically, John has traveled from the point D to E, then to point F, then to its original position, that is point D. So we have to find the smallest distance that John could have traveled. Moving further, are you able to observe the distance that John has traveled is in a triangular form? Basically, DEF is also a triangle. ABC is a triangle and inside this triangle ABC, the triangle DEF is formed. And we have to calculate the smallest perimeter of this triangle DEF. Are you able to correlate this fundamental with the fundamental of the orthogonal triangle? In the orthocenters, we have done the fundamental of the orthogonal triangle. And in the orthogonal triangle, we have studied the property that is the orthogonal triangle have the smallest perimeter of any triangle with vertices on the sides of the triangle. So we have to find the perimeter of this orthogonal triangle DEF. Basically, what is perimeter? Perimeter is the sum of three sides of the triangle. So basically, we have to find the three sides of the triangle and we have to add these three sides to get the perimeter of the triangle. Got it? So the fundamental of the orthogonal triangle will come into the picture. These are the formulas that we have done for the orthogonal triangle, and we know the sides of the orthogonal triangle are A times cos A, B times cos B and C times cos C. A, B and C are the three sides of the triangle and angle A, angle B and angle C are the three angles of the triangle. In the question, the three sides ABC are given as 4 cm, 5 cm and 6 cm. Just we have to calculate the three angles A, B and C to get the three sides of this triangle. We know the three sides of the triangle, so we can easily calculate the three angles of the triangle by using the cosine rule. That is cos A is equal to B square plus C square minus A square upon 2BC. We know all the three sides of the triangle. Let's put the value. We got cos A as 3 by 4. Further, let's apply the formula of cos B, that is A square plus C square minus B square upon 2AC. On putting the value and solving, we got cos B as 9 upon 16. Further, we got cos C as 1 by 8. We got cos A, cos B and cos C. Okay, let's find the perimeter of the triangle. That will be sum of three sides. That is A cos A plus B cos B plus C cos C. We know all the values. Let's put the value. And we got the perimeter of this triangle as 105 upon 16 centimeter. This is the perimeter of this orthogonal triangle DEF. That is the smallest distance that John could have jumped. That is the answer of the question. Got it? The question with the complex calculations. But the question is very easy, just we should know the formula of the orthogonal triangle. So the fundamental that we have used in solving this question is, the first and the most important fundamental that we have used is the orthogonal triangle fundamental. That is, the perimeter of the orthogonal triangle is the smallest perimeter inside the triangle. The second fundamental we have used is, the sides of the orthogonal triangle are A cos A, B cos B and C cos C. And lastly, we have used the formula of cosine rule. So based on these fundamentals and the formulas, we have solved the question. So that's it for the question round. We have completed a wide range of questions. Hope you have gained a lot from it. So we have done with the course. Congratulations to all of you for completing the course. Hope you have gained a lot from this course also, okay? But wait, one important thing is still pending. That is your mastery over this topic. Your mastery will not be completed if you have not completed the assignment. And try to complete the assignment in one go. Select the time and the location as per your convenience and complete the assignment in one go. Only after completing the assignment, your mastery over the topic will be completed. Okay, so that's it from our side. That is Creata classes. We believe in adding creativity to the learning. So thank you very much for being with Creata classes. Bye for now. Take care and best of luck.